Hello and welcome to another one of D's ADD videos. Today we're going to be looking at the method of undetermined coefficients. So if you've got a second order differential equation that looks like this one here, in which we have a, b, and c as constants and f of t is some function of t, there's a specific order that you must go about to find what the particular solution is. And here are the steps. Step one is to find the homogeneous solution. There's a twofold reason. One, the homogeneous solution is part of your particular solution. And two, we're making sure that there's no repeat in your particular solution. You will see that the way you come up with a particular solution is you'll look at your f of t, and if you've solved enough characteristic equations, you know that there's two real roots, repeated root scenario, or imaginary root scenario. And depending on those, you have specific solutions to your characteristic equation. Well, what you do is you look at f of t and see which one of those it falls under, and you try to follow the same basic format of f of t. All that'll make sense once you see it being done. And so you're going to look at your f of t, and if it's e to the 10t, you're going to propose a solution of a e to the 10t, some constant you don't know what a is. If it's cosine, for instance, of t, you would need to do cosine of t plus sine of t, because cosine and sine come together. Now, if we're looking at the proposed particular solution, you're going to take the number of derivatives equivalent to your differential equation. So if this is a third order differential equation, you take the first three derivatives. If it's a second order like this one is, then you take the first two derivatives. Then you're going to plug in those answers into here, simplify, and then equate both sides. All right, let's see what I'm talking about. Let's look at an example. So here we have an example, and we have got a particular solution we're trying to find for this non-homogeneous differential equation. And basically what we're doing here is we're going to set this equal to 0, find the characteristic equation. We get r equals 5, r equals -3, and then at that point we have a general solution. Now, the reason we're doing that is because this is going to be part of your solution. Also, we wanted to make sure that there's no e to the 4t, because if you look at your f of t is going to be some number e to the 4t. So what you would have done differently if it was an e to the 4t in this part of the general solution, you would have proposed a particular solution. Instead of a e to the 4t like we're going to do, we would have had a t e to the 4t. That way there's no constant e to the 4t repeated. Okay, but you see how there's no 4t here? We don't have to do that. I'll do a different example video for that. So here you could be given initial conditions for the first derivatives, and you could find c1 and c2, but that's your general solution. And now we can safely propose a particular solution of a e to the 4t, because that's a 4t right there, and some constant in front of it. You derive it twice, first derivative, second derivative, just bring down the derivative of the 4t. Now plug it into your differential equation, simplify, and when you simplify, you're going to get the first derivative times 2 is -8, -60, combine your like terms, divide both sides, a is -2. So then your solution becomes y equals c1 e to the 5t, c2 e to the -3t, minus 2e to the 4t. And again, you could have solved for c1. I'm not really concerned about that part of this video, so I'm more concerned about finding this particular solution. All right? So that was a quick example. Normally I just do examples and concepts separately, but in this case, the concept's a little confusing if you don't see it being done. So solve for homogeneous, make sure there's no repeated root, propose a solution based on your f of t, derive, plug in, simplify, and solve for a, and then do your homogeneous plus your particular. I hope I've eliminated any doubts you might have. Practice, practice, practice. Thank you, and have a nice day.